All right, first things first. Let's go back to here and we're going to do some case screening. Now, cases refer to the rows in your data set. Let's go get that data set, and then we'll look at the missing data in the rows, unengaged responses. These are potential candidates for dismissal, removing their row from the data set, and then outliers on our continuous variables. So the data, again, is right here on the home page of StatWiki. It's the YouTube SEM series. I'm just going to click this so you know I'm using the exact same data as you. Open it up. Okay, we have the data. Now this has more variables than you will need, but just barely. So first things first, we need to see if we have missing data on the rows. Let's see. Missing, nope, here we are. Missing data in rows. Now the easiest way for me to do this is actually first to organize the data. Let me get rid of any variables we don't need. Do we need playful? Well, let's go back to this model here. Here's the model. Here's the data. And do we need playful? The answer is yes. Do we need comp latent? No. Let me just delete that for now. You might want to just drag it down to the bottom of yours. I'm going to just delete it because I won't be using it. Atypical use, yes, we are using. Usefulness, yes. Joy, yes, that's enjoyment, same. Info act, yes. Decision quality, yes. Gender, yes. Age, yes. Education, no. Frequency, experience, yes, yes, and ID. I'm actually going to keep the ID because it allows us to keep track of which row belongs to which person. So we have all the data we need. I'm going to save this as something else in my downloads folder. That's fine. YouTube SEM series trimmed. Okay. All right. Now what I'd like to do is first check to see if I have a lot of missing data. I'm just going to do Control A, Control C. That's select all and copy. And then I'm going to go into Excel. Let's do a new Excel sheet here and paste that in here. And I'm just going to go to the very end. Woo! Here it is, the very end. For me, that's column AS. And I'm going to include a formula. It's equals count blank. Now what that'll do is it'll tell me how many missing values I have in whatever range I specify. So my range is from A1 to AR1, and in this first row I have no missing data. That's awesome. Just double click that and we'll see what we can get here. I have 1, 1, 2. You know what? Let me just do this. I'm going to sort by this. Let's see if it lets me. A to Z, sort largest to smallest. Now, before you start sorting data outside of SPSS, make sure you have the unique identifier in there. Because if you start sorting and you only have a portion of the data, you need to be able to match it back up. Now, in this case, I have all of the data. So what I'm going to do is if I remove any rows, it doesn't matter because I'm just going to delete all of the data in my current data set and replace it all with whatever I end up with here. But again, if you're only sorting a few of the variables or manipulating a few of the variables out of all of the variables, you need to be able to resort it in the correct order so that when you put it back in SPSS, the data for each row belongs to the right row. Hope that made sense. Okay, so largest to smallest, we can see, whoa, I have, yikes. There are these two records, 288 and 303, that have 42 missing values. That's epic, wow. Okay, looks like they didn't fill out any of the survey except whatever this question was. So I can't use those rows. They are completely useless to me. So I'm going to go over to SPSS and delete those rows. That's 288 and 303 for the identifier. Let me go over here, find ID 288 and 303. So here's the ID. Looks like it is in order, which is helpful. 288 here. Yep, missing. And you can see this one right here, 303, also missing. So I just held Control while single clicking on the row number. And that lets me select both of them. And now if I right click one of those selected ones and hit clear, it will delete those and shift the others up. So those two are now gone from the data set. Other than that, it looks like I'm doing pretty good. Just 1 or 2 missing. It's not more than 5% missing. So what I'm going to do is just impute those values. So, which variables are the ones that have a missing? No good. What I can do is go back over to SPSS and do Analyze, Descriptives, Frequencies, and just stick all my variables in there, except ID. I don't need ID. Oops. Throw those in there, and then make sure I display frequencies table, and hit OK. And this will show me right here which ones are missing data. Useful 3, and what I'm going to do, make my life easier, I'm going to copy this over, go back to Excel, new tab, paste this in here, and I know I'm going fast. You're welcome to pause, stop. You can even play these in slow-mo. If you click on the cog on the bottom right, you can put me at like 0.5 speed or 0.75 speed, and I'll still be talking, but it will be like this. Super slow. Anyway, if that is helpful. So I'm just going to get rid of the ones that don't have missing, just so I can consolidate. Okay, so it looks like we only have a few that have missing values. Oh, I didn't select gender. Here we go. Get rid of that one. Okay, so these are all ordinal Likert scales. So what we'll do for these, we'll impute the median for each of those. For decision quality 1, that's also ordinal. Experience is continuous, so we'll want to impute the mean. Now, why is that? Median for ordinal and mean for continuous. Well, in an ordinal scenario, there is no such thing as a 1.27, which might be the mean, or a 3.66. Those don't exist on an ordinal scale. An ordinal is a 1, 2, 3, 4, etc. Whereas experience could be any range of numbers. This is experience in years, I believe. So it could be anything from 0 to, well, however old Excel is, 25 or something like that. So a mean is more appropriate here, although median would work just as well. Okay, so let's go do that over in SPSS. Here we go. We're going to go to Transform and replace missing values. And let's put the ones in there that had some missing. It was useful 2, 3, and 5. So go down here, useful 2, 3, 5. Throw those in. And joy 6. There's joy 6. And decision quality 1. There's decision quality 1. And the last one was experience. Throw that in there. Okay. Well, with these guys, I wonder if I can select multiple at a time. I can. Hooray! With all of them except experience, let me expand that. I want to use, oh poop, it won't let me change them more than one at a time. I want to just replace the existing variable. So I'm going to get rid of this _1, change, and I want it to be a median of nearby points. And how many points? All points. And then hit change. Then this one, get rid of the same. But for experience, I want it to be the mean. I'll still get rid of this _1, so it just replaces the existing variable. Okay, and then I hit OK. And it says change existing variables. It says that because I'm naming them the exact same thing as I have variables named already. The answer is yes, I want to replace them. Hit OK. And at this point, if you want to play it safe, you might save as, or not this screen, you might save your data set as something else, like imputed or no missing or something like that. Now, why do we want no missing values? Well, in Amos later on, you can't do a few things if you have missing values. You can't estimate modification indices. You can't run a bootstrap, I believe. There are a few different issues that come up when you have missing values, so it's best to impute them. Now, what do you do if you have more than 5 or 10, maybe percent of missing values on a single column? Well, that gets tricky because you start, what's the word, diluting. Like when you dilute your drink with water, you start diluting the potency of the variable because you start bringing everything towards the mean. And so all of the effects, the regressions, the correlations will be diluted or dampened. And so that's not ideal. So moving on, what do we report? Well, what we could say is, let me bring this down again. what we could say in our paper is something like, we had 1, 2, 3, 4, 5, 6, 7 variables with missing values, all less than 5% missing, which we replaced with the median for ordinal scales and the mean for continuous scales, period. You also might want to say that we deleted 2 rows due to having fully incomplete responses. So more than 20% of the responses were missing, and so we removed those rows. And that's what you'd say in your report. Nothing more than that. You don't need to say exactly how many were missing in each variable and which variables they were. Just tell it like it is, like that. Okay, that was simple. What's next? Unengaged responses. So this is tricky, and not everybody looks into this. An unengaged response is when somebody is taking your survey but not really paying attention. So how do we detect this? Well, let's go back. Let me copy all this again. Control-C. And let's create a new sheet. Control-V. What we can do is visually inspect all of this data, which is kind of tricky, right? Especially if you have 300 respondents or more. I mean, that is a lot of visual inspection. So the easiest way to do this is to actually throw in an attention trap. So an attention trap is something like, if you are still paying attention, please answer strongly disagree. Or if you are still paying attention, please answer somewhat agree. And then anyone who does not answer that question correctly obviously wasn't paying attention, and so you are justified to remove their data. Another way you can do this is by recording the time elapsed for taking the survey, and then sort by that time in the end. And those who took less than whatever's reasonable, let's say you had a 60-item survey and you see many people finish the survey in under 60 seconds, that is mentally, physically impossible, right? And so clearly they were not engaged if they spent less than a minute filling out your 60-item questionnaire. Another way to do this is to use reverse-coded items. So let me go back to the survey here and go right here. And you can see here in the labels we have the wording of each of the questions. A reverse-coded item is a negatively coded item. So for playful, you can see I am playful when I interact with Excel. What if I had another question that said I am rigid or not playful or something like that when I interact with Excel? Well, you would expect them to answer in the opposite direction. So if they answer strongly agree to this one, then if you have a negatively coded item or reverse coded item, they should answer like strongly disagree for that item or something like that in the negative end of the scale. And if they don't, well, then they weren't paying attention. You can remove their row. The other kind, which is what we call a B-liner, is someone who answers the exact same value for every question. So there's one way to detect this, and that is to do an equals standard deviation, STDP, there we go, standard deviation on the row. Again, that was equals STDEV.P. There it is. And see if there is much of a standard deviation. Now I actually don't need it for this whole row. Once we start looking at gender and age, I'm no longer interested, so let me change this range here just to there. Okay, and we'll see a standard deviation, and what this is going to tell us is if there is zero variance on a row, meaning they answered the exact same value for every question. And oh, we do have one actually. Do we have any others? Everything else looks reasonable. What is reasonable? It depends on what kind of scales you're using. I use 5-point Likert scales, so maybe like a 0.5 standard deviation. There's no literature support for that. I'm just saying this is an indicator, sort of like a red flag. You can go then look. Oh, here's another one. Okay. Looks like we have two. Okay, let me scroll back up. We have two cases where, in fact, I should just sort this by this column. Smallest to largest. And 2 came out at the very bottom of 0. There you go, largest, smallest, whoops. Okay, these two rows, which are cases 19 and 295, they had 0 variance on those questions. Look, this guy answered 4 all the way across. This guy answered 3 all the way across. Clearly not engaged if you answered the exact same thing for every single question. Now, if I had recorded times, I could also see how long it took them. And so, anyway, there's a good way to detect them. What I would do at this point, now that I've visually inspected them after looking at that standard deviation, I'm going to go to IDs 19 and 295 and just remove those 2 rows. And what would I report? I'd report that I found 2 respondents who were unengaged, as evidenced by giving the exact same response for every single item. And that is fully justifiable. 19 and 295. Okay. Go back to here, ID, and 19, there he is. I'm going to right click and clear, and then go find number 295. Here we go, ID 295. This guy. I know the row number says 293, but the ID is 295. Don't get those confused. Here's 295. I'm going to delete this one. Clear. Okay, we have now looked at unengaged responses. Excellent. Last thing, outliers on continuous variables. What continuous variables am I actually using? Well, we have age and experience. Here's age. You can see it's fairly continuous. And experience. I believe this went in years, so it's up to as many years as Excel's been in existence. So let's take these two and see if there are any outliers. So how do we do this? Well, one simple way is to go to Graphs, go to Chart Builder, and select a scatter dot, just a simple one, drag that out, and on the y-axis, throw in your variable. I'm going to use experience in this case, and on the x-axis, we can throw ID in there, and then hit OK, and looks like we're pretty good, except, whoa, this guy out here. So we want to know who this is. How could we figure that out? They say they have 25 years of Excel experience. Now that is possible. Excel has existed for quite a while. Let me go ahead and sort this row, right click it and sort descending. Here's that person with 25 years of experience. How can we corroborate whether this is possible? Well, we have their age. Look, this person is 21 years old. They've been using this 4 years prior to being born. Probably not possible. So, and these 2 people have used it since they were 6 or 7. Definitely possible, so we'll leave those in. But this one, impossible. So what do we think happened here? Is this an erroneous response? Is this a useless case? You know, looking at this, they responded 4 for everything. Were they even paying attention? They're 21, 6, useful 4, 2, 2, 2, 2, 1, 1, 1, 1, 1, 2, 4, 4, 4, 4. I mean, it's hard to say whether this was an engaged person or not. 25 was the top of the scale. I wonder if they just clicked on the slider and pulled it to the right. Oh, this is a tough choice. What I'm going to do, and this is your call, I would probably delete this guy. Why? Because selected 2 for all the playfuls, 4 for all the joys. Those 2 should move together, right? And then 1s for all the atypicals. That might be valid. Oh, this is a hard decision. If you want to play it safe, then what you can do is just correct this erroneous response. What is the median for experience? Let's go find out. I have experience just over here. Let's see. Here's the experience column. Let me just get the median, or the mean. If I just highlight that whole column, you can see down in Excel, it says the average is 4.41. So let me go ahead and stick that in. 4.419, so 4.42 is what I'll stick in there. 4.42. I'm going to give this person the average, not knowing what the real value might have been, but also fairly suspicious that this is just a bad respondent. I wish I had recorded timestamps. Oh well. Okay, that was the only one on experience. Let's go do the same thing for age. In fact, if we want, we can just take age here, right-click it, sort descending. We have a 35-year-old, a 34-year-old, 31-year-old. Nothing really outlying on top. Let's sort it ascending. We have 2 people who didn't report age. Now, are we even using age in our analyses? Let's go back to here. We are controlling for age. So we have 2 here that haven't even been imputed yet, didn't respond. Let's go ahead and stick the mean in there as well. Back to Excel. Let's find out what that average was. Here's the age column. The average was 21.65. I'll go ahead and stick that in here, 21.65, 21.65. Okay, we've imputed those 2 values with the mean. And that is outliers on continuous variables. Okay, next is variable screening. We already did this. We looked at missing data in columns. The last thing is skewness and kurtosis, and then I'll start a new video. Okay, skewness and kurtosis. Back to here. Go to Analyze, Descriptives, Frequencies. And we have it all in there already except these guys. Let's throw those back in. Those are the ones we imputed. And go to Statistics. And what do we want? We want skewness and kurtosis. Continue. Continue. And here we go. If you go up to the very top, it shows it right here. Boom. Okay, right click this, copy this, go back over to Excel, and new tab, throw this in there. And what we're looking for depends on who you quote, who you cite, but a fairly liberal rule, which I'll use because I find it works just fine, is that values over 3 are problematic. If you want to be a little more rigid, there's a 2.2, and if a little more rigid, there's a 1, absolute value of 1. And even more rigid, it's something about dividing the value by the standard error and making sure it's not more than 3 times that. So let's use the easy one. Let's say 3. So if any of these are greater than 3, we have a problem. If you highlight both of those and go to conditional formatting, highlight cell rules, greater than 3, then make it red. And we're going to do it one more time, conditional formatting, highlight cell rules, less than -3, then highlight it, hit OK. It highlights these because they're not numbers, but let's go look over. Looks like we're doing pretty good. Pretty good, actually. Age is the only one. Wow, I'm surprised. Okay, so age has a kurtosis issue. And you may ask, why would that be? Well, we were sampling undergraduate students at a college. They're all like 19 to 21 years old. So, of course, you're going to have a kurtosis issue. Everything else, fairly normal, so we're pretty good there. We wouldn't need to make any changes. Now, what would we do if we did have non-normal ordinal measures? You can't really transform them. They're on a short order 5-point scale. So transformation really won't do anything. So what do? You can, if they are extremely non-normal, greater than a 3, watch them and see if they have other problems, or just drop them if you have that capability. Let's say, for example, decision quality 5 was highly non-normal. Let's say this was an 8 right here, right? Big bad 8. Then we'd say, well, we can afford to drop decision quality 5. Why? Because we have decision quality 2, 3, 4, 6, 7, and 8. We have tons of these things, and it's reflective. So dropping one item really shouldn't change the nature of the construct. So I would just get rid of it. Boom. Now, let's say you had only 1 or 2 variables. Let's say we had, let's go here. Let's get rid of these guys. Let's say decision quality only had 3 items. And it turns out decision quality 3 is highly skewed. Let's put a 6 in there. Highly skewed. What do? We only have 2 other items. This is tricky. What I would do is I would leave it in, but watch it. And if it gives you problems in the future, we may have to cut it out. If it starts giving us problems in the factor analysis, either exploratory or confirmatory factor analyses. And that's it. What do you do to report it? You'd say, well, we had 1 item that was skewed, and we decided to watch it because we only had 2 other items on that construct. Or you could say we had 1 item that was highly skewed, value of 6. We decided to delete that item from the set. You could say we also had a highly kurtote age variable, but this is expected because of the sample population. It's students, so obviously the age is going to be highly kurtote. Period. There we go. Okay, I think that does it for data screening. Woohoo!